So good morning students, hope all of you study about this total internal reflection. Okay, last class we studied about this phenomenon, total internal reflection. Okay, so before starting class, let me check how many of you have studied. All of you close your notebooks, textbooks, everything. Okay, students, listen here. After every class, today onwards, after every class, what are the things we have discussed today? You should make a note and take a photo and send me through WhatsApp. Okay, after every class, see, maybe we discuss some diagram, so just draw the diagram. Okay, every class, take the photo, what are things you have written, just make it, don't need to write detail each and every line, just a summary. What are the topics taken? Just put the date, today date, means 16, like the age 21, put the date. What are the topics we discussed today? Just a summary. Okay, maybe some diagrams we have done, so draw the diagram. Okay, so today itself, don't wait for tomorrow. After every class, you should write summary of the topics you discussed that day and send me a personal WhatsApp message. Okay, so ready? Shall we start? Okay, so today onwards, make the note also. Okay, I feel a few of them are not listening, means not giving that much importance to studies, just enjoying your holidays. Okay, if you enjoy your holidays, means you should suffer during examination. So we have to do these things. So every day you can expect the question answer section. Then you have to send this summary also. Listen very carefully. Okay, see, we already got a small list about these portions. Few topics are ignored, omitted. Few topics are omitted. Still, it's not complete. That's why we're waiting. But don't expect that the whole textbook will be omitted or like that. Maybe few topics. Okay, that's all. Don't expect much. Most probably 10% of portions. That's all. You have to study remaining topics. Okay. Okay, we can continue. Students, today, last class mainly we study about this phenomenon of total internal reflection. So there are two conditions. Light must travel from denser to rarer medium. Second condition, the angle of incidence must be greater than the critical angle. So when you mention about this total reflection, you should mention about this critical angle also. Whenever you mention about this phenomenon of total internal reflection, you should mention about this thing critical angle also. What is the critical angle? The corresponding angle of incidence where the angular refraction is 90 degree. Okay, that's only happened. See, both these phenomena, whether it's mention about a critical angle or whether you mention about this total reflection, you should say light ray must travel from denser to rarer medium. Then only it will happen. Light ray must travel from denser to rarer medium. Okay, so we are going to study about this few total internal reflection in a prism. We are going to study about prism. Okay, how this phenomenon of total internal reflection occurring in prisms. Okay, take out the textbook, page number 95. Open your textbook, page number 95. Okay, your textbook, page number 95. Total internal reflection in a prism. Ready? Okay, we can start. So we are starting this total internal reflection through a 45, 90, 45 prism. Means a prism like this. See, this prism have two angles 45 degree. Two angles 45 degree, 90. Okay. See, can anybody say, okay, you can just open your microphone and say, can anybody say, what is the angle of the prism? If your prism is placed like this, what is the angle of the prism? Can anybody say that? What is the angle of this prism? Yeah, just speak, no problem. Just speak. Okay, you can 45. How can you understand this 45? Who's speaking? Okay, okay. How can you understand it is 45 degree? How can you say that this angle of prism is 45 degree? How can you say that this angle of prism is 45 degree? Anybody? Just speak, students.
Opposite to the base.
Okay, correct. So opposite angle to the base. So in this arrangement, 45 is the angle of prism. Okay, leave about it. Okay, now just consider prism which is having two angles with 45 and one angle with 90. Okay, that is called. See, we can call this as a total internal reflecting prism. Okay, total internal reflecting prism. A prism which make the total internal reflection possible. Total internal reflecting prism. Okay, it have two angles 45 degree and one angle 90. We can arrange in different manner. Okay, we can arrange this same prism in different manner. So it's one of the method we arrange like this. Okay, so total internal reflecting prism. Now we can see, let's see what happened. A light ray through okay, listen. See, this is angle here. Just imagine a light ray reach here. Okay, see all the diagrams. Figure 4.47, 4.48, 4.49, 4.50, 4.51, 4.52, 4.53. All these diagrams are important. Any one you can expect. Okay, all of the diagrams needed part of syllabus. Okay, other than explanation. Okay, explanation no need to study much detailedly, but you should know the diagram. Okay, just imagine two light rays. Okay, just imagine two light rays reach here. Okay, see the sides opposite to hypotenuse sides. Two light rays reach here. Okay, normally what happened? Just imagine here is your object. It's your object. Okay, so normally it hold us, this point is head and here it is tail. So two light rays reach the prism. Then what happened? See, what is the angle of incidence here? Here angle of incidence is 0. So for any light ray incident at 0 degrees Celsius, 0 angle of incidence. Any light ray incidence, 0 angle of incidence. What happened? No deviation. Reach here and reach here. No deviation. Okay, because why no deviation? Even though mediums are different, still angle of incidence is 0, so deviation also 0. When it reach here from the larger surface, means side opposite to 90 degree, it will undergo total internal reflection. The light ray will undergo total internal reflection. Okay, so with an angle here, both of them are making an angle 45 degrees. You can see that a straight line to a parallel line. So if this angle is 45, here this angle also 45. So your diagram. Okay. Then what happens? See the light ray from the head reach here, reach here. So it is head and it is a tail. See, from head, from tail. Okay, see this thing. How much degree? See, from here, see it is your object. The object rotates from here to here. How many degree? 90 degree rotation. So in this diagram, we can see that the deviate light ray through an angle 90 degree. This arrangement of prism deviate the light rays through an angle 90 degree. Okay, see, listen here, one more time. Okay, otherwise I give the name A, B, C. Light ray reaches AB with an angle of incidence 0. Later ray reaches AB with an angle of incidence 0. If 0 is the angle of incidence, what happens? No deviation. If 0 is the angle of incidence, no deviation. And now reach the side AC. Okay, the light ray reach the side AC. What happens from AC? From AC, light ray undergoes total internal reflection. From AC, light ray undergoes from here. The angle of incidence is critical angle. So from the side AC, the light ray undergoes total internal reflection. See, we make an angle 90 degree from each. Okay, then we obtain, then again from this side, from BC also refraction is occurring. Again the side BC also refraction is occurring, but the angle of incidence is 0. So they gone out without any deviation. So actually these two refractions are occurring, but no change in the path of light ray because angle of incidence is 0. Okay, students, any doubts regarding this diagram? You can clarify now. Any doubts regarding this diagram? You can clarify. Anybody have any doubts regarding this diagram? You can clarify now. See, if the angle of incidence is greater than critical angle, it will undergo total internal reflection. If the angle of incidence is greater than critical angle, it will undergo total internal reflection. So from the side AC, the light ray undergo total internal reflection. See the diagram again. See, students, see the diagram again. First, it reaches side AB. At AB, what happened? The angle of incidence is 0. So no deviation. When it reaches side AC, from AC, what happened? The light ray undergo total internal reflection. Both the light rays undergo total internal reflection. Then they reach side BC. Again the angle of incidence 0. Side BC also the angle of incidence is 0. So the light ray emerged out with an shift 90 degree. Okay. See, the critical angle depends on the material. Critical angle of each material depends on this. Almost 42 is the critical angle. Okay. Almost 42 is the critical angle. In the case of glass, almost around 42. Okay, 42. Almost around 42 is the critical angle in the case of glass. I am saying this again almost only because it depends on the material of the glass. The small changes will be there. Critical angle is 42, but here angle of incidence is 45. So it means the angle of incidence is greater than the critical angle. Light ray undergo total internal reflection. So in 3 different ways. So one among them. Okay, we can use the same prism. Okay, we can use the next one. We can use the same prism only. See the diagram. Same prism only, but we arranged in another way. Same prism only, we have arranged in another way. Means here it is your 45 degree, 90 degree angle, then 245 degree angle. Let's see what happens later. Okay. See now, see this time through AB light ray center. Okay, see we have our A, B, C. This time light ray enter through AB. No, sorry, not AB, through AC. Here light ray enters through AB. Here through AC. Light ray enter through AC. What's the angle again? Angle of incidence is 0. What happened? Reached here. Okay. Through AC. Here it is through AB. It is through AC. Means largest side. What happened? Light ray undergo? No deviation. Again refraction is there, but due to the angle of incidence is 0. No deviation. Light ray reached here. From here what happened? From again the angle of incidence is 45 degree. So it means it's greater than critical angle 42 degree. It will undergo total internal reflection. Again same phenomena. Here it is angle of incidence again 45. Angle of incidence is 45. Critical angle is 42. again later undergo total Indian reflection. So this time two total reflection. Listen here students, through AC first refraction, but due to 0 degree no deviation. Here total internal reflection. Here the angle of incidence is 45. So total internal reflection reached here. Again the angle of incidence is 45. Again total internal reflection. Here 0 degree no deviation refracted out. You can take one more later. Take one more later. Reached here again total reflection. Get back. Okay. So students, see initially just imagine it is object. What happened here? See the light ray from head, the head and tail. Light ray from head is reaching here. Light ray from tail is this one. So what happened? In this arrangement, it shifts the light ray through an angle 180 degree. Here two total internal reflections are occurring. Here two total internal reflections are occurring from both sides, from AB and BC. See here and here total internal reflections are occur and shift the light ray, which shifts the object through an angle 180 degree. So both are same prism only. Both of them are same prism only. In both the prism, total reflections occur. But here, its total reflections occur from AC once. Shift the light ray 90 degree. Here, total reflection occur twice from AB and BC. Twice total reflection occur inside the prism. We shift the light ray 180 degree. Okay. Any doubt, students? You can clear. Second diagram. See in this section, wait, students, one more thing. Page number 96 at the beginning. Use, okay, that also you need to study. This actually prism is used, previous one, okay, this one. It's used in the periscope. Okay, this one is used in periscope. Hope you know what is periscope. Used in ships and all to see the things outside. It's periscope. Okay, we use this total reflecting prism, this arrangement. Used in periscope and this arrangement. Okay, 190 degree shift. We use in binocular and camera. Binocular and camera to invert image. Okay, actually the image formation inside the binocular and camera is inverted one. So we use this one again. Again we will get to get the actual image. So this one is used in binocular and camera to invert the image. What is the advantage of, see, for inversion we can use normal mirror also. For this purpose we can use normal mirror also. But this total internal reflecting prism, it have the advantage that is less loss of energy. In the case of mirror, a small portion of the energy will be absorbed. Loss of energy will be there. Here, total internal reflection, 100% of the energy is being reflected. It means energy loss is very, very small. Okay, so see actually this phenomenon of total internal reflection is better than normal reflection. Total internal reflection is better than normal reflection due to the less energy loss. In normal reflection, there should be energy loss. Say the mirror will absorb some energy. Some portion of the energy will be absorbed by the mirror. But in this phenomena, total internal reflection, full energy is being reflected. There is no loss of energy. So there is a reflection. The total reflection is better than normal reflection. There is of energy loss. Okay. Now, students, any doubt you can clarify regarding this both of this prism. Any doubts you can clarify. Anybody have any doubts regarding this thing? You can clarify now. See, explanation means what I have said. What are the things I have said? What are the phenomena occurring in each side like that? Okay. What are the things occurring in each side? That is explanation. You can write in your own words. Next one. Erect the inverted image without deviation. Next diagram. Okay. I'm erasing first diagram to erect an inverted image. See. Another arrangement. This arrangement only. But okay. Same prism only, but this time a small difference is there. Again, ABC. Same arrangement only, but this time small change, that is light rays entering through AB. Okay, through AB, but it is parallel to base. Okay, as parallel to base. Okay, parallel to base. Previous one perpendicular to the surface like the incident with an angle 0. Here is parallel to base only, so the angle of incidence will be never be 0. Okay, I will two light rays I am drawing. Listen very carefully. I have to draw this one. Okay, okay, just two light rays reach here. Okay, listen very carefully. First one put like this. Another one also. See, make sure that both parallel to each other. Okay. Again, this much height to this height, again to this height. Okay, and listen here. Okay, listen, both lights parallel to each other. Then refraction, after refraction make sure that both are parallel to each other. Then you have to reach here, see in the same level here. Here also. Then like this. Okay. It's a way you can complete the diagram. Okay, so as usual, this angle is 90, 45, 45. Let's see what are the phenomena happening. Okay, just take this light ray. Just imagine this is our object. It's an erect, inverted object. By using the prism, just see what happened. Later reach here. Rarer to denser. What happened? Bent away from the normal. So later reach here. Rarer to denser, bent away from the normal. Here what happened? The angle of incidence is almost 45 degree only. So greater than critical angle, undergo total Indian reflection. From here, total Indian reflection. Here, refraction, rarer to denser. Listen here. Here, rarer to denser. Refraction. Rarer to denser. What is the phenomena? Refraction. Here, total internal reflection. Again, reach here. What happened? Denser to rarer. Refraction. Then, moving on. Same thing. Rarer to denser. Refraction. Total reflection. Refraction. So what happens? See this image from head. It's head. Tail. So what happens? Which converts an inverted image to an erect image. This prism converts inverted image to an erect image. So without changing direction. See previous one the direction is changed. Here converting a inverted image to an erect image without change in the direction. Converting inverted image to an erect image without change in direction. Yeah, parallel. Both see light rays enter and emerge down, both should be parallel. Same direction also. This one and this one should be parallel and in same direction also. Okay. So this one application also used in the slide projector. This arrangement is used in slide projector. This arrangement of prism used in slide projector. The use also you have to study diagram, small idea. What are the things? What are the phenomena happening inside the prism? Diagram. Okay. What are the things? Just to mention diagram. Okay. What are the things happening inside the prism? Use. Okay. So this one is called erecting prism. Actually, all these three cases prisms are same. But in one case, see the angle of incidence, side of angle of incidence is changed. Which side, through which side the light ray entered, that change. Okay. Then angle of incidence change. See here, through this side, angle of incidence 0. Here, another side as parallel to base. Okay. So it's another side. So again, another phenomenon will occur. So all the diagrams are important. Okay. Any clarification? You can clear it now. So this prism means 45, 45, 90. This prism also called as total internal reflecting prism. Okay. So total internal reflecting prism. See in this diagram only 2 total reflections occur. All other 2, 1 total reflection only. Here 2 total reflections occur. So like that you have to know an idea. Okay. Any clarification? You can clear it now. Anybody? Any doubts? Anybody have any doubt? You can clear it now. Yeah, parallel. Refractor ray. Yeah, these two. See, these two parallel, these two parallel, and these two parallel, and these two also parallel. Always they keeps parallel with each other. Always this rays keeps parallel with each other. Okay. Any doubts? Anybody? Okay. So we can go to next prism. Next one is an total internal reflecting prism through an angle through where each angle is 60 degree. So it is called as equilateral prism. Equilateral prism means, hope you know what is equilateral. So each angles are 60 degree. Okay, it's a prism only, not triangle, but we are representing like a triangle. Okay, so prism, each angle. Okay, I am erasing the board. Okay, it's about prism with each angle. See, all the angle of the prism is 60 degree. Okay, equilateral, equal. So like that, 60 degree prism. Okay, just imagine a light ray reach here. Okay, just to give the name as ABC. So through AB with an angle, what's the angle? 0. Through AB with an angle 0. What happens? 0 degree, no deviation. So light ray reach here. No deviation, so light ray reach here. Here if you measure properly, you will get an angle of incidence as 60 degree. Here the angle of incidence is 60 degree. What happened? The angle of incidence is 60 degree. What happened? Normally for glass 42 is the critical angle. So what happened? It will undergo total internal reflection. Move like this. Again 0 degree, no deviation. Okay. So here angle of incidence it will reach here. Here 0 degree, no deviation, reach here. The angle of incidence is 60 degree. Okay, we can calculate, but just understand through practical experiments we can see that 60 degree. We can calculate, possible to calculate. Again refracted. Okay, do you know how the 60 calculated? Okay, no need to study, just saying how the 60 calculated. See, hope you know this angle is 90. This angle is 60. So remaining this angle will be 30. Okay. So total, see is a normal, total angle is 90. This angle is 30. What is remaining? 60. Okay, no need to know. Just how we calculate it. Just take a small triangle here. Here angle of deviation is 0, so 90 degree, 60 degree. So this angle will be 30 degree. Okay, here say around the normal, total angle will be 90. If you, this much is 30, what remaining? 60. Like that we obtain this angle as 60. Okay, then later we undergo total internal reflection. Here angle of incidence is 0, so no deviation. Okay. Any doubts you can ask? Okay. About this diagram, if you have any doubt, you can clear it now. Anybody? Any doubts? Anybody have any doubt? You can clear it now. Where, which side? I think, Alan, where, which side you are saying? AC. No, see, total in reflection means just no bending, just normal reflection. Total internal reflection means it's like a normal reflection. Reflection means I equal to R, like that or normal reflection is occurring. Reflection is occurring, not bending. During refraction only bending is occurring, Alan. During refraction bending is occurring. Here reflection. Okay, so we can say it's bending. Like a normal reflection is occurring. Like I equal to R, then angle of incidence and angle of refraction and normal lying on the same plane. Like that normal reflection is occurring from side AC. Okay, any doubt students? Anybody, any topic regarding which you discussed today? Can clear it now. Okay, see, today itself you should send the notes. Okay, I don't need to, you don't need to write each and every sentence like that. I don't need like that. But every diagram should be there. Every diagram and a rough weights. What are the happening in your own weights? Okay. To own weights, after every class, you should send the message as personal message to me. You should send as personal message. If you don't send, don't worry. I will contact your parents. I will collect the number from your office and contact your parents. Okay, write in notes, no problem. No need to waste another book. You can write in notes, no problem. Okay, you can write in notes, no problem. Okay, diagram also, draw the diagram also properly. Proper diagrams needed. Okay, almost 40, I think your total number is 42 or 43. Explanation is in your own words. Don't copy from textbook. A small explanation. See this diagram. Let ray incident within a 0 degree to side AB. So no deviation. From side AC, the angle for side AC, the angle of incidence is 60 degree. So it undergo total inner reflection. Again reach BC within side with an angle 0. So no deviation. It's an explanation. No need to each and every sentence from textbook. No need like that. I am not asking you to copy from textbook. Listen the class carefully and you should write in your own words. Okay. So any doubts regarding any topic, you can send your notes by today itself. Don't wait for tomorrow. Today itself send your notes. Okay. Else I will inform your parents. That's all. Okay. See, I feel that few of them are not at all caring about studies. Just enjoying holidays. It's no time for that. Okay. So if you don't have any doubt, you can go offline. Okay. See you next class tomorrow, I think. If you don't have any doubt, you can go offline. Otherwise, you can ask your doubts.